Degrees of unsaturation is a way of looking at a chemical formula and allowing that to give us some information about the structure. If we start with saturated hydrocarbons, alkanes, the formula can be given by the number of carbons we have, and then the hydrogens would be twice that number plus 2. That's the top and the bottom, that's the twice that number, and the 2 on the end. And so here we've got some formulas. CH4 is, if there's 1 carbon, twice that plus 2. And it doesn't matter what shape that is. If there's 8 carbons, there's going to be 18 hydrogens. 8 plus 8, 16, 17, 18. And if it's all branched, it's still going to be C8H18. So we have 3 here, 3, that's 9, 10, 11, 12, 15, 18, still 18. If you've got a chlorine or other halogen on there, I want you to notice that it just replaces the hydrogen. So instead of it being 2n plus 2, I took away some number of them because I had halogens on there. If there's 1 chlorine, then there'll be 1 less hydrogen than you might expect. If there's 2, then 2, etc. So here we've got just strict replacing of the hydrogen, strict replacing of the hydrogen with the bromine, strict replacing of the hydrogen with the fluorine. And if we look at the formulas, if we take the 4 H's or the 3 H's and the Cl's, still everything says that there's the right number of attachments to that carbon, that it is saturated. Same thing here, C3H8, H7F, etc. Now, if you happen to have an oxygen in the molecule, it's not exactly like the fluorine, the chlorine, or the bromine, because those actually counted as hydrogens, and this doesn't count as a hydrogen. As a matter of fact, it doesn't matter at all. If you've got an oxygen just tucked in here between the carbon and the hydrogen, it doesn't change the number of hydrogens. It's just stuck in between. And the same thing here, and here can go either way, still the same thing. And so here we've got some formulas. Notice that's still CH4, CH4. Oh yeah, there's an O. The rest of the formula is the same. Oh yeah, there's an O. So if you're looking at the number of hydrogens and the number of carbons here, you would say that looks a lot like ethane, which doesn't have any double bonds. And here's this oxygen. Okay. Now, if you've got nitrogens in here, something interesting happens. You end up with usually an odd number of hydrogens, because instead of it being like oxygen where it just snuck in between, there's an extra one here. So this was CH4, but here we've got 5 hydrogens, and this was C2H6, and here we've got 7 hydrogens, etc. So when you've got nitrogen, you actually end up picking up an extra hydrogen, so you kind of have to cancel out one of those hydrogens. You'd say, well, I have a nitrogen, so take one away, and that would give me CH4. So this is going to be a lot like methane. If I had this one, take one away, it's going to be a lot like ethane. Now, those molecules did not have any degrees of unsaturation. They had, if you will, the right number of hydrogens for that molecule. But when we start putting in double bonds and things are unsaturated, we start losing hydrogens. So if you compare the ethane and the ethene, we go from 6 to 4. Those 2 missing, if you will, hydrogens are missing because we've got this double bond here. And if we know how many we've got, we say, hey, there's 2 missing. That lets us know that we have a double bond in this molecule. Same thing here. There's 2 missing by the double bond. Same thing here. There's 2 missing by the double bond. And if we look at our formulas, we've got C2H6. Oh yeah, and we're missing 2 hydrogens. That implies missing 2 hydrogens implies 1 degree of unsaturation. 2 hydrogens missing means you have 1 double bond, 1 pi bond where you didn't have a pi bond there before. 1 place where you're just not full of hydrogens. And the same thing here. 2 hydrogens are missing, you have 1 double bond. 2 hydrogens missing, 1 double bond. Now, if you have more than 1 double bond, you're going to be missing more hydrogens. So here we have butane, and then here we have 1,3-butadiene, and I want you to notice that we're missing, this one had 10, this one only has 6. It's missing 4. That implies there's 2 double bonds. So the 4 missing hydrogens, you're going to divide that by 2, because 2 go with each double bond. And you're going to say, hey, this molecule has 2 double bonds. And this is hexatriene, same idea. Hexane, and missing a whole lot of hydrogens there. Okay, so if you look at this, it's missing 6 hydrogens. 14 minus 8 is 6. And that's because we have the 3 double bonds there. But if you know it's missing 6, you could say, I guess there's 3 double bonds there. Now, if you've got a cycloalkane, this doesn't have any double bonds in it, but it does have a ring in it. And when you hook the 2 ends together, if you were to hook this carbon directly to this carbon, this H and this H would go away. So number-wise, it looks very similar to having a double bond. So if you have a ring, you're also having a degree of unsaturation. You're also having 2 hydrogens less than you might expect. And again, we're down 2 hydrogens. That's 1 degree of unsaturation. Now, if you have a triple bond, okay, so here we had the ethane, the ethene, the ethyne. And I want you to notice we keep dropping off on the hydrogens. Okay, we went from 6 to 4 to 2, and it's missing 4 hydrogens here, which is because there's 2 pi bonds. So this triple bond is 2 degrees of unsaturation. 1 sigma bond, that's normal, and then the other 2 bonds are unsaturated, pi bonds. And we can calculate that. And the same thing here with the propane, propene, propyne, okay? In all of those cases, we've dropped down, and so we've gone from 6 to 4 to 2 as we add degrees of unsaturation, 8 to 6 to 4 as we add degrees of unsaturation. Now, this also works when you've got aldehydes and ketones, which have a double bond to an oxygen. The other molecules had double bonds between carbons, but same deal works. Remember, we had the alcohol where the oxygen is sort of slithered in between, but here we're going from methane to methanal. We're going from 4 hydrogens to 2 hydrogens. So we have a degree of unsaturation, and that's that double bond, that pi bond between the carbon and the oxygen. Similarly here for the ethanal, and here for the propanone, which is also known as acetone. And if we notice, there's 2 versus 4, 4 versus 6, 6 versus 8. In each case, there's 1 double bond in this molecule, 1 degree of unsaturation. Now, a particularly interesting case is benzene. This is benzene over here, and we see that these are aromatic compounds. Okay, a lot of them are fragrant, but we don't use that as meaning fragrant anymore. We use it as containing benzene rings. And it's C6H6, and here, of course, we have our hexane, which is C6H14. And if we take a look at this, oh dear, we have 14 down to 6. We're missing 8 hydrogens. That's 4 degrees of unsaturation. Well, 4 degrees of unsaturation is almost always going to be jumping out at you in a molecule, even if the molecule has more dangly bits, as a benzene ring, because there's the alternating single and double bonds, okay, which is 1, 2, 3 degrees of unsaturation, plus the ring itself. So every time you get a benzene ring, you're going to end up with 4 degrees of unsaturation. Now, this is sort of a summarize. First, you need to calculate the number of missing hydrogen atoms, then you divide it by 2, and this gives you the degrees of unsaturation, which tells you the number of pi bonds or rings in your molecule. going to find it. It's here somewhere.